Hello and welcome to a revisiting of Module 3. I thought I'd go back to that in part because I know some are struggling with it. So as a refresher, Module 3 deals with reading and writing files in both Python and R. So I thought I would go over basically kind of what the assigned reading is and then talk a little bit about how you do it in Python, how you do it in R, and there's variations, and then maybe do a little bit more of a walkthrough. So jumping straight in, what are files, right? It's important to have the distinctions. Three kind of broad classes, and actually XML is kind of a special case. Files include text, binary, and then XML is basically a text file that's structured a certain way. It's done typically through a form of a convention. There is a definition of what is valid for an XML file. There is also a way of enforcing essentially a schema on a file. But it is, at the end of the day, a text file, so it does fall underneath of that same broad category, but it's a special kind of text file, just as JSON is a special type of text file as well. You could think of it as almost like a CSV in the sense that it's expected to follow a certain protocol, but the protocol is a bit more complex for XML than it is for something simple like a CSV. Then deliverable 3 is all about working with files, basically reading and writing files, those three types, XML, binary, and text, in Python and in R. So the reading, recommended reading is out of your Python text, chapter 6, and out of the R book, chapters 12. Feel free to use other resources, always a good idea. Don't just stick to those. So moving into Python, when we talk about reading files, there's a bunch of kind of native things that are available. Read CSV, read HTML, and lots of other stuff. So keep in mind there are lots of different ways to read files, and so that's one thing to keep in mind. There's kind of varying levels of complexity. Sometimes you want to use something like pandas and do a read CSV off of pandas. It's much simpler. Other times you need to do something in a more chunking sort of way so that you are doing it over greater control. The code you see on the screen there is an example of how to read an XML file in Python. And you'll notice that with block, and what the with does is basically control the scope of the thing that is returned from open, which is XML file. That's essentially a file handle is the way to think of it. And whenever you use that, you can pass it into a function called XML to dict, which basically converts it into a dictionary. And you give it that file .read as a means of doing it. And then once it's done, before you exit the scope, it's still open. So you can see that XML file.closed is false. As soon as you exit that scope, it closes. So there's really no point in doing the following line there where I say XML file.close, because it's already been closed at the point it exited the scope of the with clause. That's an important concept to understand, is scoping and especially things like with, which are a way of managing scarce resources, and file handles are considered to be a scarce resource. So what is XML? A very valid sort of question, and one that may not be familiar to a lot of people. The short version of it is that it is text. It's a textual representation of data, so it's not a binary format. And it uses tags, and those tags have to match. So whenever you have an opening tag, you must have a closing tag. That's the rule. The exception to the rule, as there always are exceptions, is the line below, which includes an inline closing. So basically this line opens and closes the tag all in one go. It says some tag, and then you terminate some tag here, and it does have an attribute on it. It's impossible to nest text between with this sort of structure, but you can, well, not impossible, but it's not appropriate. But you can add an attribute onto the tag. Sometimes the tag's existence is sufficient, such as a paragraph tag inside of HTML, or XHTML more precisely, indicates that something should happen just by its existence, so it doesn't necessarily need anything nested inside of it. But tags, generally speaking, are nested. So in the screen you see there tag A contains a tag B, and and at the same level as tag B is a tag C, but tag C includes tag D. That's the same representation as the string you see there. And the opening and closings have to line up, so You can't like open A, open B, open C, and close A. You have to close them in kind of a reverse order, so they have to construct a tree, and that's an important characteristic. Tags can have textual bodies, such as the tag of Alan was here as the body of the tag, and at the root there's a single node, and it's basically the document node. The document node has a single node, which is the root node. So that's one of the things to keep in mind, is that there has to be a tree. It has to have one parent per tag. So it's a very restrictive sort of structure in that regard. Does introduce some problems whenever you start dealing with processing XML, because generally speaking, especially data scientists, we're dealing with data that is tabular in nature. That's kind of how we normally deal with stuff. Whenever you deal with nested data, you have to do some extra work to make it work out, and that's one of the challenges with this particular assignment. So generally speaking, it can be challenging to process XML. Primarily because you're taking something that's hierarchical in nature, a tree-like structure, not tabular, and you're trying to do, generally speaking, tabular stuff with it. So oftentimes you'll select a subset of the things that are available because that's all you really care about. Generally speaking, you're going to probably use a object model, document object model, which is a means of interacting with an XML document in a way that looks like you're dealing with objects. And then sometimes you'll use XPath and XQuery as a means of extracting and selecting data out of an XML document for you. So starting with a simple sort of approach. So first, XPath, a little bit of an introduction. And there's some magic sort of ways of knowing this, right? It's kind of like a query language. You can think of it that way, to where there's a way that you can select values of interest using things like the question mark, or I'm sorry, the dot or the star, or the particular tag's name, or / means to search from the current location pretty much all the way down, or the relative location depending upon where it's applied. Dot means to go up a level to your parent. You can also have attributes where you potentially apply an attribute condition, so that you say, give me back the authors where maybe their age, if it's an attribute, equals some value. You can also look for particular tags, look for text that's associated with a given tag as well, so the body of the elements. So it's a non-trivial topic, but it is something that may be worth learning depending upon what you're doing in XML. Here's another kind of an example. EndNote is a tool that's used to track references. So I took an EndNote library, extracted some references from it, and saved it off to an XML file. You'll notice that it is very tree-like in nature. The root node is called, not very originally, XML. The very top thing up here is a tag that tells you that this is an XML document. It's not an XML tag unto itself. It is basically a way of adding metadata, and more importantly, it's telling you that it is encoded in UTF-8. That is one of the things that's important. Sometimes you have to augment the XML text itself so that you can say things about it. Sometimes you'll also do things like say, this is the schema that goes with this particular XML document. So that's one thing to keep in mind. The records are variant in nature. What that means is that they may or may not have all of the particular sets of attributes. There's probably, or tags. There may be some that are essentially required, like record number may be required, but most of the others may not be. So it's important to kind of keep that in mind when you're processing XML, is that you have to be kind of defensive in how you code it, because things may not always be present. So here's one solution. There's lots of different ways to do this type of processing, but what I'm basically using here is an XML library called from in the namespace of XML, and then I'm using an E tree, an element tree, to basically be able to do the work. So to work our way through this code, and I'll potentially show it to you in a moment, we start off by doing the typical import OS. So we pull in it's primarily so we can do a join. This combines together these two strings in a safe way, and in this case it'll make sure that there's a slash between data and my EndNote library so that it'll come up correctly. Then we basically are saying, okay, we're going to do some XML in here, so I want to import XML. We're also going to do some element tree stuff, so import element tree as ET pandas so that I can construct a pandas data frame. And then the last thing I do in this cell is basically execute a parse command, giving it the file name that we constructed up here, and what returns back is a tree. We take that tree and we're going to do some stuff to it down here, but before we get there I'm going to define a couple functions that'll make life a little easier. So what get xpath text does is pull the text back of the element that matches the XPath query that's passed in. We also have a couple extra things here that make life a little easier. So we give it the XPath that we're interested in. We give it what is the current record in the tree that I'm processing. And then a flag that says if it's required or not. And all that does is that if it's required and it's not present, then it's an error, is basically what I'm doing. And then if something unfortunate occurs, I probably want to be able to print out something that tells me where I'm at so I can figure out what's going on. So that's what this debug info is that as we're calling this function, we're giving it something to display on the screen if something unfortunate were to occur. And that can make your life a lot easier. It's one of those hints, is to give yourself a bit of a conditional display of when things go bad, you may want some additional diagnostics. Get XPath attribute pulls back the attribute of a given node that matches the query, the XPath query that we pass in. So we basically give it an XPath, we check and assert that there is a value present, and that's going to raise essentially an exception if for some reason it's not exactly 1. So if there's more than 1 or 0, you'll get an error. And part of the reason is because I'm saying here, give me back for the node that matches the attribute that is passed in as the value, so the attribute name. So whenever we go through the root, we basically say to the tree, give me the root node. That's the topmost of the element. In the case of this particular example, it's going to be XML. And then underneath of it, there's a collection of records. So what we can do is say, give me for each of the records that is in the root, so we're going to nest through them, I assert that it's going to be records. So we're making some assumptions here. There's one XML node. Underneath of one XML node, there is a records node. Within that records node is a collection of records. So we're basically embodying that expectation with this command. We're saying whenever you see we expect that the record that's going to be underneath of here is records, and we expect that underneath of the records is a record, and that's essentially what we're doing. Then I can call a series of commands here that basically use this get XPath text and get XPath attribute to extract the values that are of interest to me. So I want the record number, I want the style, and I do expect it to be there. I would like the publisher style, and the publisher style is actually the name of the publisher, right? So in the case where there is a publisher, and I'm looking for one on this one and I don't see it, so we'll go back one. In the case there's a publisher, you have a style here. Inside of the style you're going to have text. In this particular case, I'm probably looking right at it, but I'm not seeing, oh, there's one right here, publisher, Oxford University Press. So here we got a publisher. Underneath of the publisher we've got a style, and the text node of that style node is the text that we're interested in. So that's what we're extracting with these functions. And then basically I'm controlling if they're expected or if they are allowed to be absent or not by passing in true or false with the expectation of the path. So I give it the path. I give it some diagnostics here, so I'm telling you the string number or the record number as a string on each one of them so that I can track down the record that gives me grief, and then we could potentially diagnose it, right? So that's the whole point of all that. And then once we extract those values, I turn around and construct an empty record here, so basically an empty dictionary, and then I set title, publisher, and so on, and then convert that dictionary, add it as a row to this this row list, and the row list is simply an empty list, right? Equally well, you could have added it. So at the end of that, you're going to have a list of dictionaries. I could have also created a pandas data frame and added using append as well there, a record to the data frame. So to see it in motion, here we are reading the XML, and it's loading it up. Then we're parsing it. Then I define my two functions and I call my code that basically loops through it, and you can see I get back an array or a list of dictionaries basically. So that's what all these are, and so it worked pretty much as desired. Another approach that you might want to do is convert it to JSON, and then the reason being sometimes things are easier to deal with in JSON. So we do have the ability here to do an XML to dict, which takes in, as the name kind of implies, an XML string, returns a dictionary. And then the dictionary has a series of, essentially it's a nested tag sort of thing. So using that approach, and there's lots of different ways of doing this XML processing. And that's one of the things, again, as I've said before in this course, is there are a lot of different ways of doing the exact same stuff in this course. So whenever you're doing this, you'll import, in this case, XML to dict using PyPy. So, pip install or whatever to install it as needed. Once you've installed it, it can then convert your XML into JSON, and then sometimes it's easier to deal with JSON. So in this case, what this is doing is converting it into a dictionary of dictionaries, and then basically here I'm just dumping the JSON out so that you can see it in the JSON format instead. So that's the basic idea here, is that we're converting this into an ordered dictionary of tags and then an ordered dictionary of additional tags. So one approach that you might use is to use those dictionaries then to extract the values you're interested in. But again, you've kind of got to be cautious here, and that's why all these try catches are about, is because not everything is present all the time. So in this case, this is really kind of hackish and not something I would recommend. I'm trying to get publisher style text. If it's not there, then I set it equal to an empty string, but I don't check for it. I just try to do it. And this gives you an exception that is then accepted and then flown through. That's using exception handling as a flow control, basically. Never a good idea, primarily because it's, first of all, it's not pretty. Secondly, it's potentially performant impairing, because the performance of this sort of approach is not good, because oftentimes you have to do actual interrupts and a few other things to make these things occur. And then at the end of this, I'm constructing a data frame record and then appending that data frame record to this empty pandas data frame that I created up here by defining the columns. This part, it's not too bad, right? But this other, yeah, probably you don't want to be doing that, because it's not going to do well whenever you get a bunch of things. So whenever we run this, you can see that it is not exactly fast whenever I go to run this through. So the reason being is there's a whole bunch of things going on inside of the kernel potentially that are making this slow. You're interrupting the processing, and that causes things to kind of stop and go into a certain state, and then you're kind of resuming. And so you can see there, not a real good user experience, and not probably going to be very good if this goes to be really, really big. So why so slow? Try except. That's the reason. And again, as I've mentioned, exception handling should not be used for flow control. Instead, you should check to see if something's there rather than just assuming it's going to work and doing it. So that's why it's better to foresee, especially those things that you know are going to be the case. Now, if it's something that it's really rare for a value to be absent, but it's okay if it is, then it might be acceptable. But in cases where maybe more times than not it's not present, probably not a great idea. So a better approach is to do something that checks to see if it's there before you attempt to use it. And also by extracting out a lot of that common code, I can introduce a little cleaner approach. And it's perhaps a bit more complicated because it does rely on recursion. But the way that it works is that we construct a series of those same records that we were using back here. So, right, we have the things like titles, title, style, and text, and publisher style text, and so on. So a series of essentially indexes into those dictionaries of dictionaries. So rather than doing them that way, we can basically make a list of essentially items. So we're looking for publisher, and so on a publisher we're looking for style, and then we're looking for text. The same thing with dates, year, style, text. And so this is a list of things so that as it comes into this function, you pass in the current dictionary and along with the list of keys. If for some reason there's no dictionary passed in, we assume we're done. If for some reason there are no keys passed in, we assume we're done. That's to handle the case of something not being present. And this is essentially a form of tail recursion. I believe. I'd have to double check, but I think it's tail recursion. So, but it is recursion because what we do here is say that if the length of the keys is equal to 1, then we get that one key. And that is the value that we're returning. We check and see if that key is present in the current dictionary's keys. And if it is, we return it. So this is actually head recursion because we're coming out before we go deep. The next test here is that once we've we've came in with either one or more keys, if we've got more than one key, so it's greater than 0, probably not all that important to be greater than 0. It could be just greater than 1. But we then pop the first thing off of the list. So in this case, it'd be something like title or XML, depending upon when we're coming in. I'm sorry, XML or publisher, depending upon what's coming in. And we pop it off, and that becomes the current key that we're looking for. We then look in the current dictionary, which in this case is the top level dictionary, for that item. And if we find it, if it contains it, then we take that associated dictionary. So we've got a dictionary of dictionaries construct going on here. So nested down any number of levels deep, depending upon the hierarchy that's going on. We can take that current key, grab the dictionary that is associated with that key, and then we pass those two things along with the shortened list of keys after we've removed the one that was at the top level into this same recursive function and can continue the process until we hit this condition down here where we either we run out of things, which means it's not present, or we find it, we're down to the last item and we return back that last item's value, or an empty string if it's not present. And so we basically do assert here that the list of keys shouldn't, this basically is saying this should never happen. So if it were to happen, then something really unforeseen has occurred. Likely somebody changed our code and didn't know what they were doing. So that's basically how this approach works. It's perhaps a little complex to understand, but you do get the nice semantics here, almost like the dot notation, right? So seeing it run to get a sense of the difference between what it's like with this versus what it's like with the other approach. And you can see that it is definitely a lot faster. So not that speed is necessarily the primary concern, but whenever you start talking about things like maintainability, this becomes a more important concept as well. Also, if you go from a few megs to potentially really, really large XML, you want it to be as efficient as possible. Probably wouldn't be using this approach on a really large XML file anyway, because it is kind of putting it all into memory, and that's something, it's a different conversation. But it is something to think about. So wrapping up the concept here inside of processing XML, of extracting information and potentially converting it into something else, it's critical to understand the nature of the format of the documents. You need to know the structure. You need to know the mechanics behind it, how it's organized, what's nested inside of what is accessible, what is not. Generally speaking, you want to avoid flow control being done through exceptions. Generally speaking, you're going to want to extract some of the information from an XML document. Probably aren't going to get it all, but you might. And then assert may be your friend. So you want to probably consider that you using asserts to essentially capture and document your perceptions of reality is an important thing to keep in mind. And then moving over to R and R file processing, some foundations. Again, thinking of it from an XML perspective, you generally speaking want to use this concept of an apply. Apply is a way of essentially doing something similar to a Lambda function in Python. It's a way of basically saying, do this on each one of the things that's inside of this list, or whatever it might be, matrix list, whatever it might be. You can also it'll take essentially those three parameters, an array or a matrix, and then tells how do you want it processed, row-wise, column-wise, rows and columns, and so on. And basically what it'll do is then apply the functions that you're supplying it. So in this case, we're adding things up by using the sum function by either column-wise or row-wise and getting back the results. And so that's the foundation understanding. You kind of need to know that to get to this next thing, which is around lapply, which is around working on lists. It basically takes two things: the list that you're interacting with, and a function. Awful lot like probably a map function or a lambda function, depending upon your background. And you've also got this concept of an sapply, which works on list vectors and returns data frames, or data frames, and it returns a vector or a matrix, sorry. So it does work list vectors, data frames. You get back either a vector or a matrix, going to depend upon the dimensionality of what you pass in. And then tapply, similar concept, function to a vector using a factor. So moving on to having laid that foundation, you may want to do an R project. It's up to you. If you're using the R IDE, you may want to create a project because it's a way of kind of combining together things that are related, similar to a project and some of the other IDEs that you might be familiar with. So one of the ways that you can do the XML processing in R is to use this XPath sapply, and that's a mouthful, right? But basically what it's doing, if you take a look at the code that's on the screen, is exactly what we would like to do. It allows you to take an XPath and essentially get back a value. So in this case, we're constructing a data frame, setting authors, record number, publisher, year, and so on, using this XPath function that I define up above to extract the values of interest and return them back into the values in the data frame, right? So at the end of it all, you get back exactly what you would want: a data frame containing the things like the title, the authors, the record number, and so on of each one of those publications that happens to be in this thing that we've been looking at, the EndNote library that I exported. So things to keep in mind. That is one way to do it. The few references here, Learning R and Python for Data Analysis, those are both good resources as well. So moving on to deliverable 3, deals with data files. Scenario, key takeaway here is that you're interested in supporting different file formats, which include these 3, and you need to do so in both R and Python. So your instructions, there's 2 distinct submissions for this module. The first one, you demonstrate your reading and writing of text, binary, and XML files within Python. So you read, write, all 3 of these things. So kind of 6 combinations: read in the text, write out the text; read in the binary, write out the binary; read in the XML, write out the XML. You don't necessarily have to do a whole lot of XML processing, but it does need to be able to demonstrate that you can parse it and print it out, and print out in particular specific attributes of interest. So you may want to read in one XML file and write out a subset of the attributes that you care about. Or you could add additional attributes. That would be probably fair as well, but it does say print out specific attributes of interest. So you want to be able to extract the value of certain attributes. It does need to at least be 1K in size. 1K XML file is actually kind of considered small, so keep that in mind. And you're basically demonstrating the parsing of the XML language and so on. In both cases, you submit your source code. Make sure you give me source code in a plain text file. This is very clear in the instructions. Plain text, so .r, .py would be kind of what I would expect. If you want to put .text at the end, that's perfectly fine. But I do need your source code along with any input that was used and ideally associated output. The rubric, you want to shoot over here, the rightmost column, mastery. You've got an R programming language. You used R programming language to read data sets that included text, binary, XML that was at least 1K in size. Include code to do some significant error checking to ensure it was successfully read in R. So that means you want to do some checking, plus make sure you're reading all those things in, and then use a more complex data set for the R program that includes more than one type of data. such as integers and strings, and also includes missing data. So that's how you get over here, is basically make sure that you have more than things that are just not just strings, but make sure there's some numbers in there or dates or something, and then also make sure that there are some absent values. Also write the data set. So you read them in, you have some attributes that are of certain types, you write them back out, those three things, text, binary, and XML. You fix any imperfection data such as missing values. Maybe you set missing values with an empty string. That's simplistic, but also potentially appropriate. Or maybe you set empty integers to some predefined constant, -1 or 0 or whatever's appropriate. Then create new variables before writing the files. So you want to add something to it, maybe a date timestamp or something of when you read it and processed it. It doesn't have to be extravagant, just add some new attribute, some new either feature that maybe could be do some feature engineering. Take two attributes and use them to construct a third that you then write out. That would be perfectly valid and actually fairly common. Then moving on to the Python side of things, use the Python program to read the data set, text, binary, and XML that's at least 1K, and then do significantly more error checking to ensure that the data was read. So do some either error checking or some investigation of the nature of the data so that you can determine if it was read correctly. Use more significant complex data sets for the Python program that include more than one data type, so integers, strings, and some other stuff, and again missing data. Then write the data sets using Python, text, binary, and XML. Use significantly more logical rules to fix imperfection of anything that might be missing. Remove some of the variables before writing the file. So maybe exclude some and then maybe create some new ones. So that's basically the rubric. Taking a quick look at some of this code, this might be worth taking a look at just as kind of an example. Yours will likely look different, but in this case we've got three inputs and three outputs named appropriate. In this case doing a little bit of stop words, some text processing on that file. You don't necessarily have to do that, although it is kind of interesting if you choose to. And then basically here we're opening up some files, in this case the text file. We're reading in the files. We're doing some processing of basically converting them into lowercase, and we're reading until we run out of lines, and then we're doing some regex replacement to look for some strings, and then a few other kind of fun stuff of looking at some punctuation and so on, and then at the end of it we're writing those things out. Right, and then we continue the loop by doing a read line at the end. This is a common pattern with a while. You prime it up here by doing a read before the while, then you check to make sure there's something in that line that you just read. So this is reading until as long as the line contains something, and then once you get to the end of your logic, you read again to keep yourself inside of that while loop. And then you close up your files and move on to the binary side of things. Very similar sort of thing, and then some XML processing as well. So that's roughly what your R program might look a little bit like, although do make sure that you make it unique to yourself. Taking a quick look at some Python that might also show a similar approach. So in this case, a similar sort of approach. We've got an input folder, then we've got some input files, output files, maybe not the most Pythonic naming convention, but appropriate. And then, so the idea here is to, again, parse the XML, getting that root, looping through the root, very much like what I did. This has an assertion that we expect the tag to be a book, and then we go through and create a dictionary, and then we add that dictionary to a list. So we're constructing a list of dictionaries, and we're using item.find to look for things that are of interest, and then if we find it, we grab the text. So very similar sort of approach to the one I just showed you, slight variation on the theme though. And a similar sort of approach here is that we've read all that into a list of dictionaries. We then create a data frame from it. Then we're going to go through and create essentially a root node of a tree, and then we're going to add things to it, writing out each one of the rows that we just constructed in that data frame for the length of it, essentially, loop through it, adding them to the XML tree, and at the very end we'll write that XML out. So that's one of the basic ways of doing this. So does kind of show you some things you might want to do. This is getting close to some natural language processing. Tokenizers are things that convert strings into a series of tokens. Tokens are simply just pieces of things, right? So generally speaking, it would be a word most commonly is how you would think of it. And so basically this is basically going through and tokenizing a file, returning back a series of tokens that have been filtered out to remove those things that are alphabet only characters, so get rid of things that aren't. And then so we're tokenizing the file, we've got some words, and this is literally writing those words out. Probably not exactly, doesn't necessarily contain different data types per se, or missing values, but it's really pretty interesting, so I'd definitely let that one slide. And then here we're creating a word cloud using those words that we constructed up here, and then doing some binary reading and writing of some files. So reading a file, writing it back out down here. So reading here and writing here. So in a nutshell, that's kind of the stuff you'd want to know about. And I was just showing the wrong screen through all that. So let's go through this again very briefly. So I talked and you didn't get to see. So here's the basic code. So this is the Python we just talked about, or I just talked about. A bunch of imports to get things set up. XML input and text and binary inputs, and these are the outputs. And through here we basically parse the XML input, grab the root node, then turn around, loop through it, extracting those things of interest using the find command on the item of interest in the current thing, using essentially an X query, basically is what that is. And then if it's not none and that does contain text, so the node is there and it does have a text node, then we grab that text and save it off to the value of interest. Could be a little cleaner perhaps, but acceptable. Then we construct essentially a dictionary or populate a dictionary here. We set the values of interest with the values we just extracted, add that to a list of dictionaries. Then we will basically take that list of dictionaries, convert it into a data frame, a pandas data frame, and then loop through that pandas data frame, writing out the rows of interest, the values of interest, and into a file. So we're basically constructing another XML file from it and then writing it back out. This is the part where I was talking about a tokenizer. It's a tokenizer method. It's kind of an advanced topic. You can definitely do something other than this if you're so inclined. But basically what it does is read a file, return back all of the alphanumeric or the alpha words, then construct a word cloud from it using this word cloud library. And then this is showing the binary reading and writing of binary files. So there's lots of ways to do this stuff. This is one way. And then quickly the Python or the R, I just showed you the Python. Similar sort of approach. You define the variables. These are the paths where things are, then the file names of interest. And so to open them, we basically are saying combine together the input path with the text file, and open that as a file A. File B is what we're writing to, so we're reading from A and writing to B. Read in lines from A, priming the loop, as I said previously, on the while loop. So we read something first, then we check to make sure that we loop until we don't get anything back when we read the file. We're also writing it out as we go, so we're reading in a line, doing some stuff to it, and writing it back out, and then closing the file. Binary files, similar sort of concept. Open up both the read and the write binary, and you want to include that B there to indicate that it is a binary file. And then we read in one record, or basically 1 byte, I would assume. Yeah, 1 byte. That's an integer, and then we write that out. As long as we're getting stuff again, priming the loop up here, and then reading again at the end of the loop, and then checking to make sure we actually got something here, and then writing it out. And then the XML is very similar to kind of some of the stuff I did inside of you're basically using a similar approach, but using a dollar annotation to indicate the attribute. So we say XML data $ attribute, and it's a way of essentially denoting an attribute of interest on a node, and then again looping through the rows, writing them out. So with that, I will wrap this up. Do make sure that if you use any of the things that I showed you, modify it sufficiently, or give credit so that you're not getting into any gray matter or gray areas with plagiarism. So with that, I'll wrap this up. If you have any questions, let me know. Stay safe, and do keep in mind we're on the tail end of this course, so I'll try to respond quickly, but when you get near the end, it's going to get potentially quite dangerous for you. So do try to get everything caught up as soon as you can. And stay safe, and I will talk with you on Wednesday.